and good afternoon, and welcome to this video tutorial on Packet Tracer Activity 6.5.1.3. As you can see here, if you look on the top of the Packet Tracer application, this is actually for the CCNA 1 course, and this is the Packet Tracer Skills Integration Challenge for CCNA 1, or Introduction to Networks. So let's go ahead and take a look over here to the right-hand side. We've got our addressing table, and we're going to be filling in some of the information over there as we go along. Objectives are to finish the documentation, and that's going to consist of our default gateway information. We're going to perform some basic device configurations on both the college router as well as the Class B switch. We're not going to be able to access Class A switch, but we won't need to in order to successfully complete this activity. We're then going to verify connectivity and troubleshoot any issues. So here is the requirements section that we need to go through. So let's go ahead and dive in. So the number one activity says provide the missing information in the addressing table. Well, if we're taking a look at our topology here, it's a little odd the way things are laid out, but needless to say, we've got a 172.14.10 network here, and this is a /24. And remember that this is what we refer to as CIDR, or CIDR, Classless Interdomain Routing Notation. I could also represent this as 172.14.10.0 with a subnet mask of 255.255.255.0. And again, we've got 8 bits in each of these octets. Remember, we have 32 bits total in the net mask as well as the IP. So all 8 bits are on. The value is 255. So we've got 8 bits, 8 bits, and 8 bits in the subnet mask that are on. So 8 plus 8 plus 8 gives me that /24. And so that's where we come up with the CIDR notation. If we look down here toward the bottom of our network diagram, you can see that we have a 172.14.5.0/24 network. And so these two networks are basically separated from each other by this router. And this router is going to provide the inter-VLAN connectivity, or I should say not the inter-VLAN, but the inter-network connectivity that we require, which is so student 4, student 3, student 1, and student 2 can all communicate with each other. And so the college router is going to facilitate that. And what that means is this interface right here, which I believe is probably gig 01, and this is probably gig 00, those are going to be our default gateways for the respective networks. So switch Class A and student 1 and student 2, their default network will be that IP address right there. If we take a look here, college gig 00 is the 14.5. It looks like I had it backwards. So this is going to be gig 00, and this interface right here is going to be our gigabit 01. And you can tell because they've got the network information right here. Now, there is no default gateway for the interfaces on the router because the router is going to be providing those default gateway interfaces. So let's go ahead and, well, actually, if we fill the information here, it's going to end up getting wiped out. So, but let's just say for VLAN 1, the default gateway would be .5.1. And for the Class B switch, it's going to end up being .10.1. And so we're probably going to have to configure these two interfaces here, along with some of these other requirements, in order to get the full credit for the points. As you can see, it's kind of interesting. We start with 15 points down here. So it looks like it gave us 15 points right out of the gate. We haven't done anything yet. So there's 85 points that are out there for the taking. And let's go ahead and jump on the command line here and take a look at these requirements. Let's clear our screen. So the first thing we have to name, sorry about that, we're going to name the router college and the second switch Class B. So let's go ahead and do that right now. We'll start with the router. And here we are at the router login screen. You can see I'm in user exec mode right here. And that's what that greater than prompt represents. When I type EN for enable, that's going to put me into privilege exec. Now this becomes important because you can see the next two requirements are going to be adding a password for user exec for all lines, so that would be our VTY lines and the console line, and then the subsequent requirement is going to have us put the enable password in order to get into privilege exec mode. So again, to get into privilege exec mode, we just type en, or in other words, we're typing enable. Okay. And you can type disable, and that was what happened there. So when I was in privilege exec, so when I go from user exec, which is the greater than sign, to privilege exec, which is the pound sign, if I type exit, it's going to log me out, and that's what it did there. So in order to avoid that, if you just wanted to go for whatever reason from privilege exec, the pound sign prompt, to user exec, the greater than sign, you just simply type disable, right? The opposite of enable. Again, if you type exit, it's going to go ahead and it's going to log you out. All right, so let's get logged back in. We're going to go from user exec to privilege exec, and we have to get the host name set. So to do the host name, we have to go into what they call global config. And this is where you see the router prompt, and we have in parentheses the word config, meaning we are going to be applying global configuration settings. And these are the settings that affect the router globally. Well, if I say host name, which is what I want to do, and I want to name the router college, you can see that the prompt actually changed, and it changed immediately. And so remember, with Cisco IOS, that's one of the important things to remember, is that when you make a change, that change takes effect immediately. There are some other vendors that are out there where you're working with what they call a candidate configuration. So Juniper with JunoS is one of those vendors where the changes that you're making, you actually have to commit those changes. So in other words, it's kind of like you're working with a piece of scratch paper, making all these changes, and then you have to commit them. With Cisco, as soon as you make the change and hit enter, that change is going to take effect. So the host name has been changed to college. So let's go ahead and address let's go ahead and walk down, and we'll take care of everything for the router here. So it says use Cisco as the user exec password for all lines. Well, if I say do show run, and we scoot all the way to the bottom, there's an auxiliary line as well, but I don't think it's going to make us do anything with that auxiliary line. So we're going to deal with the console line. So I would say line con 0, and I would say password, and we want to set that to Cisco, and I'm going to say log in. Now I had to put the login word there, right? So I set the password on the console line, and I added in the word login, because again, I need to tell the router that if someone's attaching to the console line, that in order to log in, they need to enter in the password Cisco. You can see here on the VTY lines, the login line is already there, but it is not there for the console line. So we add it in. And then let's go ahead and say line VTY 0 to 15. And again, we're going to simply say password. And actually, that is not, oh yeah, that is correct. Yeah. So that is the password. So all of the lines have been taken care of. So we've got the do show run. Let's go to the end here. So you can see we have password Cisco, and we have the login command on all of the lines. Again, I don't believe we're going to have to go into the line, excuse me, the auxiliary line 0. If we did, we could certainly put the password, put the password on there and log in. All right, so we're just going to do that for completeness. You'll notice that if you were watching the points down here, the completion, we're at 27, and that doing it to the auxiliary line did not move the needle at all. So my guess is we don't need it, but we'll throw it in there just to make sure. All right, so now we need to go ahead and use class as the privilege exec password. So again, that privilege exec password, if I type in disable here, is when I type enable, I should get prompted for a password. So let's go ahead and set that up. So we'll do that from global config, and we say enable, and now we have two important choices here. The first one is if we said enable password. Now the problem there is that that is going to produce a type 7 password. And again, type 7 passwords are very elementary to crack. In fact, you can simply Google crack type 7 password and you're going to hit 1,000 sites. And you would literally, all you would have to do is cut and paste the password in, and it's going to decrypt it for you. So we want to go with secret. Now, again, Packet Tracer is not the full-blown iOS. It's not full-blown Cisco iOS. And in some cases, with previous editions, and I like to call that out now, that this is version 5.1, which is the latest and greatest version for the CCNA 1 course. These Packet Tracer activities are all version 5.1. I'm using Packet Tracer version 7.0, right? So this is the latest and greatest for Ubuntu. And I'm using the version 5.1 CCNA Packet Tracer activities for CCNA 1. So I'll make sure I point that out, because in past activities, even though the best practice is to say enable secret, because that's going to give me a type 5 password or an MD5 hash, which is much more difficult to crack, that sometimes the Packet Tracer activity wouldn't give you the credit for that, that it would want you to put in enable password for whatever reason, even though it didn't specifically say. But best practice, and what you should always do, is the enable secret. So we're going to go ahead and say enable secret, and the enable secret is going to be class. So CLASS, and let's see if that moves the needle, and it does. So now when I say exit and then disable, and I type enable to get into privilege exec, I'm presented with the password prompt. And then we would type in class. And again, this is a best practice because you don't want users to be able to transition into privilege exec without having to enter a password in. And the reason for that is once I'm in privilege exec, I can go directly to global config, at which point, if I wanted to, I could change any setting on the router. Right? So this gives me full control. Once I get into privilege exec, I have full control over the configuration of the device. The next is to enable all plain text, or I'm sorry, encrypt all plain text passwords. And so we do that from global config. If you remember the command, it's service what? Password encryption. You've got it. So we're going to type in service password encryption here on the router, and that will now encrypt all of the type 7 passwords. So if I say do show run, let's go down to the console lines. Now take a look here. It no longer says Cisco. Now, to be clear, these are type 7 passwords, and these are, again, very easy to crack, but Cisco is very upfront about the fact that the type 7 password is not implemented to stop hackers from cracking into a router. Right? That is not what the type 7 passwords are for. The service password encryption command, which provides these type 7 passwords, is for what we call the shoulder surfer. So it could be another employee, it could be a friend who's looking over your shoulder trying to see what you've set the password to. Maybe that individual goes back to their desk and then tries to log in at a later time to do something nefarious, right? And so that is really the only purpose of the service password encryption, and the fact that they use type 7 passwords for these lines, right? Or for these passwords that we have set on the different lines, because that is going to be a lot more difficult to remember if I'm glancing at it super fast than the word Cisco, right? So if I were to see Cisco, I would be like, oh, okay, they're using Cisco for the password on everything. But if I see this, I have to remember this random string of characters here. So, and that's the only purpose that type 7 encryption serves, really, right? Is just for the shoulder surfer. It is not there to stop the hackers from getting in and cracking the passwords. All right. So we've encrypted all plain text passwords. So let's configure an appropriate banner. Well, we do that with banner, and we have some choices here. We could set a login banner or an MOTD. So let's do both. I'll say banner MOTD. Now the next character I enter in here, I'm going to use a $sign. That's the character that I'm going to enter on a line by itself once I've typed in my banner. So I could simply say, this is my banner. We'll say authorized users only, right? And again, on a line by itself, once I'm done, I put in the $sign. And that tells the iOS, the CLI, that I've completed entering in the text I wish to use for my banner. So that was what we just did for the MOTD, the message of the day. Let's put a banner for the login as well. And we can simply make it the same thing. In fact, let's kind of, we'll make it a little nicer here. This is typically how I set up my banners. This is a private system and unauthorized use is not allowed. And so you can get a little creative here. And then again, it's a $sign on a line by itself. So when I say do show run now, let's see if we've got, and there they are. So we've got the login banner, which we're going to see when we try to log into the router. And then we've got the MOTD, which we also see when we log into the router. All right, so we've configured banners. Now it says configure addressing for all devices according to the addressing table. Well, we're on the router, so let's say do show IP interface brief. And that's what we're looking at right now. You can see we've got the gig 00 and the gig 01 interfaces. They're completely unconfigured. In fact, they are shut down because we can tell that from this administratively down, right? So let's go ahead and change that. Let's go into interface gig 00. We're going to add the IP address of 172.14.5.1, and that's going to be our default gateway address for that VLAN. So we'll put our subnet mask in there, the 255.255.255.0. Again, that's a /24. And then finally, I want to say no shut. And you can see that it's going to bring that interface up. In fact, if I click back into our diagram here, you can see that we've got spanning trees probably running down here. We can't get onto the Class A switch, but these will both go green here in a second as soon as spanning tree finishes its work. So let's come back onto the router and let's finish with gig 01. And the IP address there is 172.14.10.1. And again, it's a /24. So 255.255.255.0, and then we say no shut. All right, so at this point, everything has been configured. So let's type end, and that's one way to go right back from global config to privilege exec, where we're going to say write mem. And this is the same as copy running config to startup config, except without having to type all of that stuff in there. You can just simply say wri mem, and that does the same thing. All right, so that takes care of the college router. And now it looks like we need to transition over to the switch. And so let's do that now. And as you can see, we've got all green here, right? So things look good. And in fact, before we do that, let's check, can we ping the default gateway here from student 1? So we're going to pull the student 1 PC up. We'll go to the desktop. Let's take a look at our IP config. So if I roll this up just a skosh, you can see we're 172.14.5.50. That is the student 1 address. And so our default gateway is going to be 172.14.5.1. So we'll close that down. Let's pull up, oops, not the terminal. Sorry about that. Pull up the command prompt and let's say ping 172.14.5.1. All right, fantastic. We've got connectivity. How about, can I ping student 2? So what if I were to say ping, and we should be able to do this because student 2 should be in the same VLAN, 172.14.5.60. And we can. All right, so we've got connectivity down here. Let's make sure student 2 also has the default gateway. Yeah, it looks like they're going to have us add that default gateway in here, .5.1. And then let's confirm, can we ping the default gateway 172.14.5.1? And we can. All right, fantastic. So we're good there. So the 172.14.5 network down here looks like it's properly set up. So now let's come over to the Class B switch, and let me bring this up a little bit to the center of the screen. And we've got some work to do here on the switch. So again, we go from user exec, which is the greater than sign, to privilege exec with the enable command. Privilege exec is indicated by that pound sign. And then from here, we need to go into global config with configure terminal. And that's where we see that config in parentheses telling us, hey, you are in global config. So let's put our host name onto the switch, and this is going to be called class-B. And you can see it takes place immediately. We're going to set the user exec password for all lines. So do show run. There shouldn't be any auxiliary lines here, and there aren't. So we're going to say line con 0, and we're going to say login. We'll do password first. Password is Cisco, and then login. And then we get into the VTY lines, right? Remember, the console is actually the physical port on the back of the switch or the router that you would plug what they call a rollover cable into. The VTY lines, those are our virtual terminal lines. So when you're SSHing to the router or the switch, or you're telnetting to the router or the switch, you're connecting to the virtual terminal lines, or these VTY lines. And so the login command is already there, so let's go ahead and set the password to Cisco. All right. Now, let's go ahead and, whoops, I wanted to stay in global config there. Use class as the privilege exec. So enable secret class. And again, remember the difference between enable secret and enable password. Enable secret gives us a best practice type 5 password, whereas enable password gives us a very simple to crack, highly discouraged password or encryption type that you don't want to use for the enable password. All right, encrypt all plain text, so that's service password encryption. So do show run on the VTY lines down here in the console line. You can see that everything has now been encrypted. And configure an appropriate banner. So let's say banner, and I think we've got just MOTD here. So banner MOTD, this is my switch. Please log off now. All right, so that is going to be our banner. So configure addressing for do show IP interface brief. So do show IP interface brief is going to show us any IPs that have been configured. And you can see we've got VLAN 1 here that is administratively down. If you refer back to our addressing table, you can see that VLAN 1 on the Class B switch is going to need to be configured, and we're missing the default gateway. Well, we know that the default gateway would be the router interface for that VLAN, which is going to be 172.14.10.1, because our VLAN 1 IP is 172.14.10.35. So let's go ahead and make those changes right now. We're going to say interface VLAN 1. IP address is going to be 172.14.10.35. And again, this is a /24 or 255.255.255.0, and we have to throw that no shut in there to bring that VLAN up. And it says document interfaces with descriptions, including the class B. So we're going to have to go back to the router, actually, but that's okay. We'll put in here, and we'll just say this is my VLAN 1 IP address. All right, so we've got a description there. Now, what's interesting here, and before we get to that, let me go back to the router, and let's get into global config, interface gig 00, and description, and we'll just simply say VLAN 172.14.5.0/24 net, and interface gig 01 is going to be the description is going to be the VLAN for 172.14.10.0/24 net. So we've got our descriptions there. We'll save that config again. And now let's come back to the Class B switch. So if I'm on the Class B switch, let's see, can I ping my default gateway? 172.14.10.1. I'm sorry, I put the wrong IP in there. Let's see, Control-Shift-6 is going to bail us out. It does. So 172.14.10.1. Sorry about that. All right, so 172.14.10.1. So we can ping that. Let me see, can we do a repeat? Okay, we can only do the 5 pings. All right, so we're able to ping the default gateway, but can I ping the switch on the other side? So can I ping class A? So if I say ping 172.14.5.35, can I ping class A? And I cannot ping class A. So why do you think that is? Well, let's go to the router college. So from this router, right, which is directly connected to that switch class B, can I ping class A? So let's say 172.14.5.35. And I can, right? It's directly connected to me. And when I say me, I'm the college router. And the college router is serving as the default gateway for the Class A subnet. So it makes logical sense that we've got connectivity up to this interface. But we don't have connectivity through. And so that might be a problem. So let's check student 4. Let's see how student 4 is configured. 172.14.5.60. And you can see we've got a typo here. If we look over here, and let me lower this down just a bit, we're on the student 4 PC here, which should be 172.14.10. And in fact, if we look, it's 172.14.10.60. So not sure if that is a typo or if they intentionally have that in there to try to throw you. So let's make sure we get that fixed. 172.14.10.1 is my default gateway. And now, can I ping? So ping 172.14.5.35. So I'm pinging from student 4's PC to the Class A switch. And I can ping it. Let's see if I can go beyond the Class A switch. Can I get all the way to 5.50, which is PC 1, or I should say student 1, and 5.60, who is going to be student 2? And I can. So what do you think is missing here? And we're pretty close to having just about everything done. So let's go ahead and do student 3 and take a look at the desktop. Let's double check that IP, 172.14.10, so we're good there, and 50, that's correct. So 172.14.10.1 is going to be my default gateway. And let's run some ping tests now. So can I ping the student 1 PC, 172.14.5.50? And I can. And what about 5.60? I can. So the PCs, student 1, student 2, student 3, and student 4, all have full connectivity through the router and through the switches. But for whatever reason, we can't ping the Class B switch. And this is often a common point of confusion for CCNA learners, is that we need to remember that there's a difference between what we call transit traffic, which is traffic that's going through the switch. So when student 3 pings student 2, the traffic is destined for something, some destination beyond or through the Class B switch. So this is called transit traffic, where the traffic is going through the Class B switch. And then we have control plane traffic, right? So, and again, sometimes it's referred to in planes, right? The control plane and the data plane. So this transit traffic is the data plane, right? It's traffic that's just, it's going through the switch. That's it. But what about traffic that's destined to the switch? So student 3, when it pings student 2, doesn't say, I'm pinging the student 2 address that's on the Class B switch. It doesn't say that. What it says is, I'm just trying to get beyond the switch to student 2. And so when we're sending traffic directed for the switch as if the switch were a PC, because we can telnet onto the switch. That's why we manipulated the VTY lines, right? So you can SSH to the switch. So that's not transit traffic or data plane traffic. That's considered to be control plane traffic from the switch's perspective, because again, that would be traffic destined for the switch. And in order to do that with the switch, just like student 2 and student 1, student 3 and student 4, they were kind of queuing you. The activity was giving you a queue that what did we have to do on all 4 of these PCs? There was one common criteria that we had to set for all 4 of those. Exactly right. The default, and boy, my pen is dying on me here. The default gateway had to be set on all of these PCs, right? Because when we're sending traffic that's destined to the PCs, if it's going to be returning to a different network, so when student 1 pings student 4, we're going from the 172.14.5 network up to the 14.10 network. So the PCs, in order to be able to respond to that traffic, must have the default gateway set. And it's no different when we're talking about switches, is that switches also need to be able to know, hey, if traffic is coming to me from a different network that I don't know about, I need to have that IP default gateway setting, or else the traffic is not going to know how to get back to that other network. So let's do the same thing. So that we did for the PCs, we do it on, we do it on the Class B switch, right? The Class A switch we can't get to, and it's already been done there. So we go into global config and we say IP default gateway, and the default gateway for the Class B switch is going to be 172.14.10.1. So now, when we have traffic that is destined to the switch, control plane traffic coming in as an SSH connection, a ping connection as ICMP traffic, or I think I said telnet already, telnet and SSH, right? If it's coming from a different network than Class B is configured for, it now knows how to get to that network. So now let's try from the student 1 PC, and let's ping, where are we at here? Let's ping 172.14.10. And what did we give the Class B? 35. And take a look at that, right? It works like a champ. And so to prove that this is the same for the PCs, I'm going to go ahead from student 1, let's ping student 4. So I'm going to ping 10.60. And you can see right there that it works, right? Perfect. If I come up here to 4 and I pull off this default gateway and close that down and come back to student 1 and try to ping again, what happens? It's not working, right? The request is timing out because student 1 is sending out those ICMP packets with the ping command, but when they get to student 4 is receiving them. They're actually getting here. But then when student 4 goes to reply, student 4 says, well, the only network I know about is the 172.14.10. And I don't have a default gateway set up. So again, this is why on the Class B switch, for traffic destined to the switch, control plane traffic, we have to have that default gateway setting in there, just like we do for the PCs. So 172.14.10.1. All right, so we've got that sorted out. Let's come back over here to to student 1, and take a look at that. It works like a champ. All right, so where are we at? We're 97 out of 100. So provide the missing information in the addressing table. We are good there. We named our routers. We're good there. We did the Cisco as the user exec for all lines. We're good there. Class as privilege exec. We encrypted all plain text passwords. And let me confirm this here. We'll say end write mem. And so we're still missing 3 points. And let's say show run. All right, so you can see we've got the host name is correct on the switch. We've got class as the enable secret password. And let's see. Encrypt all plain text passwords. We did. An appropriate banner. We did. Configure addressing for all devices according to the addressing table. We did that with the VLAN 1. We've got our default gateway on there. Document interfaces with descriptions. Okay, we've got the description on. And I'm wondering, are they actually looking for... Let's see here. What do we have? That's, I'm hoping that's going to give me the interface that's on. And actually, I should be able to, I'll be able to find those 3 interfaces by simply saying do show IP interface brief. Sometimes if you mouse over, so here's what I'm looking at here, right? So these 3 up interfaces, well, 01, 05, and 08, are they actually looking for the descriptions there? So let's go ahead, interface FA01, and this is description uplink to my router named college. And take a look at that. Interestingly enough, it jumped to 100 before we even finished. So then let me go ahead and say interface FA05, and the description here is going to be, we'll say student PC, and interface FA08, and description student PC. Again, if I wanted to figure out which one, I could simply say shut, and then come back and say, well, yeah, that's definitely student 4, right? So if I wanted to spice up my description, student PC number 4, right, to be a little more accurate, and then go back to, what was it, 05? Yeah, 05. Interface FA05, and say description PC, or student PC number 3. And I think we need to go into and say no shut, if I'm not mistaken. There we go. All right, so we say end, and then we say write mem. All right, well, we are 100 out of 100. We've got some spanning tree convergence that's going to take place here, but that's going to work on its own. So this wraps up Packet Tracer Skills Integration Challenge 6.5.1.3, which is from the CCNA 1 Introduction to Networks curriculum. And this is the version 5.1 Packet Tracer activity, because there is a version 5.02, I believe, and a version 5, but this is the latest and the greatest. All right, thanks so much for watching. I hope that's cleared up any confusion you had about this activity, and especially that IP default gateway setting, right? Very, very important on the switches. All right, thanks for watching, and have a great semester.